practical exterior lighting. Having covered the vast majority of the important V-Ray features and settings in modules 1 through 8, I want to use this module to demonstrate how to apply many of the things discussed in earlier modules to an exterior scene that I worked on in the past. And when doing this project the first time, I experimented with various render settings and material settings to get the look that I wanted, but like most veteran users, I tend to use the same general approach to each particular type of scene. For example, I usually render exterior scenes with an irradiance map and a light cache, and usually start with my typical test and production settings. But every scene is at least a little bit different and a little bit unique, and all are going to require at least some experimentation. Also, situations do occur from time to time that warrant using other methods than the one you rely on most often. In this module, I'm going to show numerous different lighting and rendering approaches and provide a review of as many different V-Ray features as I can. I'll describe the process that I would go through to light and render this scene, and then I'll describe some of the other ways that you might approach your scenes based on what the final product is, the time that you have available, and problems that you might encounter along the way. And I constantly tell students over and over again that knowing V-Ray well means knowing how to troubleshoot your scene. And by this, I mean knowing some good settings will rarely lead to efficient quality renders because, as I just stated, every project is different, and settings that might result in a great look to one scene might result in a horrible look and excessive render times on another scene. What can really make your work agonizing is struggling with the myriad of problems that can arise with any project. Problems like splotches, noise, flickering GI, strange dots, running out of memory, excessive render times, system crashes, lack of detail, and so on. So the goal of this module is to demonstrate a good approach to a typical scene, and then I'll intentionally create some problems with this scene and demonstrate some of the ways to fix them so that you can apply the same approach when you run into the same problems with your scenes. So let's go ahead and start, and if you want to follow along, open the file called hampton01.max. This is a project that 3DAS worked on for the hotel chain Hampton Inn, and just so you can see what I'm going to try to reproduce, here are the final rendered images. Now, rendering a scene of this size will take too long to show in real time, so most of the time when I render, I'm going to immediately skip to the final image rather than making you wait each time. It just wouldn't be practical to do it any other way. Also, in this project, I used a program called Onyx for all the trees and plants, and unfortunately I can't distribute these models, so the scene that I've made available contains no landscaping. Landscaping will obviously change the look and feel of a rendering, but when you're working on a scene in a production environment, I would either hide all the vegetation anyway to minimize render times, or I would just wait to populate the scene after the lighting has been set up. So I wouldn't be rendering with these objects in the scene anyway, at least for test renders. Therefore, I'm not including the vegetation in this tutorial, and that should be just perfectly fine. Likewise, I can't distribute the cars shown in one of these views because they were purchased through Sure 3D, but those two would not be shown during the lighting setup anyway. I want to give a little background information about this scene before I begin. It's a fairly small scene which contains about 930,000 faces, not including the almost 10 million faces contained within all the V-Ray proxies that you see around the scene. The V-Ray proxies in the scene were basically the 3D cars that you see, the 3D trees in the foreground, and in the background I have a standard 3D background rig that I use for almost every scene. It contains two cylindrical objects which are visible with the camera but not visible in reflections, and it also contains a hemispherical object which is visible to reflections but not actually visible through the camera. Notice also that I'm using 2D trees in the distance to break up the horizon line. You never want to see the horizon unless it's on the water, so to break up the background, I scattered various 2D trees around the perimeter of the scene as well as some individual faces which at a distance looks like underbrush. And this is a really good way to create backgrounds for your visualizations. It's simple, it's streamlined, it doesn't take very long to render. And if you want to read more about this, you can check out the Visualization Insider article entitled A Little Background Information, and that's on CG Architect. One more important note I need to make about the background rig is that all the objects that make up the background are illuminated independently of the rest of the scene. The three sky objects are illuminated by a single omni light positioned directly in the center of the background objects, and the 2D trees are illuminated by four direct lights positioned around the boundary of the scene. And this was done so that the brightness of the background objects could be controlled easier and separately from the rest of the scene. And I'll be talking more about these background objects a little later, but what's important to note right now is that any light that I add to this scene will automatically want to illuminate these objects. So what I need to do each time I add a light to the scene is to exclude these objects from the effect of the added light. And I'll demonstrate this when lights are added. Finally, if I click the background dome or cylinder objects and select V-Ray properties, notice that I've disabled the Generate and Receive GI options. This is important because these objects are very large relative to the other scene objects, and if these options were enabled, they would cast a tremendous amount of GI on my scene, so much so that they could completely change the appearance of whatever skylight that I use. Okay, well, before I add my first light to the scene, I want to highlight something really important about any scene that you work on. The brightness of a scene is obviously dependent on the intensity of the light sources, but it's equally dependent on materials in a scene. As you probably know, in the real world, dark colors absorb light and bright colors reflect light. Well, in V-Ray it works the same. I often see users trying to add lights to their scenes before applying materials, but the problem with this is the illumination they're working on is so dependent on the materials because the materials bounce or absorb light. So I would always recommend applying materials before placing the first light. Obviously the materials don't have to be perfect, but they should at least be close. To demonstrate just how much the materials in the scene affect the illumination, here's the same scene from the top view, and this shows the site elements before materials were applied. Now to show you the effect that these colors have on your rendering, here's a rendering showing just the building and the basic site elements. A single direct light is being used to simulate the sun, and materials have been applied to the building but not to the site elements such as the grass and the roads. The site elements started as line work imported from AutoCAD and converted into 3D models. They contain the same colors that the AutoCAD line work contained because materials simply haven't been applied yet. When rendered, it's clear to see that a great deal of light is bouncing all around the scene. Notice that in direct light, shown striking the north side of the building here, the building's objects don't appear to be receiving as much bounce light as they do when objects are in shadow. This is actually not the case. They're actually receiving more bounce light because the light striking the ground objects in front of this end of the building has a lot more energy and more light gets bounced onto the north side. It only appears to be receiving less GI because the bounce light is so overpowered by the direct light. On the east side of the building, where no direct light is being received, the illumination of the building is at the mercy of the surrounding objects. Trying to light the scene at this point would be a wasteful endeavor because once you apply the real materials to the site, it will look completely different. It's going to completely change the amount of light and color striking the building. The point is, you should get the materials as close as possible before trying to get the lighting right. Getting back to the scene with materials already applied, I'm ready to start working on the lighting, and the first light that needs to be placed in any scene is the strongest light, which for an exterior daytime scene is obviously the sun. There's only two different types of lights that I would recommend using to simulate the sun, and that's the V-Ray sun and the standard light. Like real sunlight that strikes the earth, both of these lights cast parallel rays, and I recommend avoiding the use of other light types such as Omni lights or the V-Ray plane, which are simply harder to control and usually less efficient with the energy that they throw out. Unlike the V-Ray sun and direct light, other light types don't cast perfectly parallel rays, and placing them too close to objects can cause hot spots to appear. One other possible option would be using the photometric sunlight daylight system, but I personally haven't found the same kind of speed and ease of use with these features that I found with the V-Ray sun and the standard direct light. You can certainly use the photometric feature for shadow study, but beyond that, I would stick to the V-Ray sun and the standard direct light. So the first thing I want to determine is from which direction to have the sun strike the building. In this project, this end of the building faces north, and with the sun in the southern hemisphere, sun will be striking both long ends of the building evenly. Most clients I've found care less about the correctness of the light orientation and the shadows, and more about whether or not the visualizations look good with any particular light setup. Only a small percentage have ever cared to ensure that the light is placed in a real-world fashion. This project was given to us solely for the purpose of winning city approval, which for this project was difficult because the proximity of the building to a major highway shown here just 60 feet away. It wasn't because of the difficulty in determining where the shadows were going to lay. So the money shots in this project were these two shots from the east, and these were the important shots that needed to have direct sunlight on them. The third shot was a less important shot used more for marketing purposes down the road. So after making the decision to show the project from these two perspectives, I know that I want to place my sunlight right about here. I'm choosing this particular area because I always want to show one side of a building in full sunlight and another side in shade whenever possible. With the sunlight position here, I'll get some good illumination on the east side of the building, and I'll get some good shade here on the north side, which just so happens to be where the shade would actually fall in real life. So just as a side note, if this side of the building were the south side, which naturally would receive sunlight all day long, I would still, in most cases, choose to keep the sunlight position so that this end stays in shadow. I do this because having one side in shadow like this gives the rendering depth, whereas having both sides illuminated with direct light, which is what I would have if the light were behind the camera view right here, having both sides illuminated with direct light has the tendency of flattening out a rendering. If you have a view of a building where only one side of a building is to be shown, as in this image, you should never place the sunlight or any other light directly behind the camera because this can really flatten out a rendering. In this type of rendering, I always try to shoot for a 45-degree angle to the sun. In other words, the sun's off to my side, off in a corner of the scene, and with this I get good shadows. So to me, this area here is really the only place I would even consider placing the sun, regardless of whether or not it would allow for real-world accurate shadows. Just to make sure that I currently have no illumination sources in my scene that would affect the lighting that I'm trying to set up, I want to go ahead and render the scene as is. First I need to enable global illumination, and when I render, you'll see that the sky is illuminated just fine by the single Omni light, but the building is completely dark. Now the sunlight is usually the only light that needs to be placed in an exterior daytime scene, although you can certainly use fill lights whenever you want. But for now, this is all I want to use. So I'll select the V-Ray Sun and place it in my selected area. And I'm going to choose to use the V-Ray Sky Map when asked. The V-Ray Sky Map is a really great choice for skylight, and in most situations is what I like to use even when I don't use the V-Ray Sun. Mainly because the skylight it provides changes as you change the position of the sunlight or whatever light you use. Also, just like in the real world, the color and intensity of the skylight changes from one surface to another based on what part of the sky a surface is facing. So surfaces facing straight up should receive less intense skylight and more of a colored skylight than surfaces facing the horizon. Now, after placing the V-Ray Sun in the top view, I want to switch to a side view and move the sun up in the sky a little bit. I want to move it up about 60 degrees above the horizon. I don't want to move the sun directly overhead because I won't get good shadow length. So about 60 degrees is what I usually go for. Once I place the sun, I need to reduce the intensity multiplier. If I were using a V-Ray camera, I could leave the intensity at 1.0, which is the default value, because a V-Ray camera has exposure control built into it, and that's what that 1.0 was built for. But since I'm using a standard camera, I don't have exposure control, and an intensity of 1.0 would be far too much. So with a standard camera, I want to start off with a value of 0.01. Okay, I want to check what I'm working with at this point, so I'll render here as is. I want to mention that I'm using all default values with this initial rendering, and with these default values, I'm going to have to wait a long time to see this rendering get completed. The default values are far from what I would call ideal, especially for test renders, so I'll stop the rendering in progress and show you what it would look like when completed. this rendering took 12 minutes 58 seconds, which is far more than what I should have to wait for to get a decent image. So the next thing I want to do is get some good test render settings established. I want to leave the radiance map set as the primary bounce, but this high preset that you see here provides far too high resolution for test renders, and really even for most production renders. So I'll drop this to the lowest preset, very low, and the next thing I want to do is change the hemispheric subdivision values, which is far too high, and I want to drop this to 20. Making these two changes alone could cut my render time to a fraction of what it was before. I also don't want QMC for the secondary bounce because it's far slower than light cache, and although more accurate, I don't need accuracy right now when I'm just starting to set up my lighting. If I determine later that the light cache just doesn't give me the quality I need, I can change it later, but for now, light cache is the way to go. So after switching to light cache, I want to reduce my subdivisions to a suitable test render setting. This subdivision value is the most important setting here in light cache, and I'm going to start with a value of 150. Remember that doubling this value means that light cache takes 4 times as long to calculate. So take that into consideration when doing test renders with the light cache. Next, I see that the rendering is too bright in some places and too dark in others. I might want to use exponential color mapping to control this, but I always like to try to use Reinhardt to start with and a burn value of 0.5. And this gives me a good mixture, a 50-50 mixture of linear and exponential. And linear and exponential rarely work in their default configuration, and you'll usually end up having to adjust the bright or dark multipliers. But I always like to see if I can get away with using Reinhardt because it often provides a nice look when the burn value is adjusted properly. So with color mapping set to Reinhardt and the burn value set to 0.5, the last default change I always make during my first test renders is to change the importance sampling to 100%. So inside the QMC rollout, I'll increase the adaptive amount to 1.0. And this can really speed up my renderings. So this is the typical setup I use for test renders, and in this configuration, the scene will render very fast. And I'm ready to do my first real test render, and when completed, this is what I have. The first thing that you should notice is that with these test settings that I use, I cut my render time down from 12 minutes 58 seconds to 2 minutes 28 seconds. And as fast as this render is, I'm actually rendering about twice as many pixels as I would need for standard DVD quality renders. So for an animation, this rendering would be about half this value. It would take about half as long. I'm using a Core 2 Duo laptop with 2 gigabytes of RAM, so it's by no means the fastest available machine. Well, I no longer have the burned out areas, but my scene is too dark overall. So I want to see if I can fix this by increasing the V-Ray Sun multiplier. I could choose to increase the color mapping burn value to something a little higher like 0.75, but that would make the color mapping a little more linear, and I don't think that's going to prevent the really dark and really bright areas from coming back. So I want to try increasing the multiplier value to 0.015. But before I go ahead and render, I've noticed that I have a small area of sunlight striking this corner of the building here, which to me seems a little bit distracting. It just so happens that the placement of the sun has caused the shadow to appear right next to this corner. So before I render, I want to move the sun a small amount to the right just so that the shadow line moves farther to the left and doesn't become such a distraction. So inside the top view, I'll move the V-Ray Sun a little bit to the right, and now I'm ready to render. And when I do, here's what I get. Well, unfortunately, even though the areas in direct sunlight seem to be illuminated okay, the areas in shadow are still far too dark. Increasing the sun multiplier would help out in these dark areas, but it would cause all other areas in direct light to get burned out. So I really only have 2 options right now to fix this. I could always add a fill light with shadows disabled and the intensity set to about 1/4 of the sun's intensity, and this would certainly be a decent solution. I could even just make a copy of the V-Ray Sun and slide it over so that it's striking the north and west side of the building, or whatever view I want to render. But instead of doing that, I want to try my more typical approach of adjusting the color mapping. So I'll switch the color mapping to exponential, and try this type of color mapping with the default settings. Now, I probably should have mentioned earlier that even though these steps are exactly the same steps that I would be taking if I were working on this project for real the first time, I wouldn't be taking the time to render the entire image each time I do these test renders. I would instead be conducting renders of very small regions, just large enough to give me a sense of the effect that each change that I make has to the entire scene. So these test renders would actually be about 1/20th of the time that you would see shown at the bottom of these renderings. Now with exponential color mapping, this is what I get. Notice that the hue and the saturation in this image is slightly different than in the previous image, in which I used a 50-50 mixture of exponential and linear. I could decide at this point to preserve this hue and the saturation that was lost in this rendering using the HSV exponential option rather than exponential. But I actually feel that the color shown in this rendering better match what I'm trying to achieve, so I'll leave it set here to exponential right now. I like the illumination on the east side of the building in direct light, although it could possibly stand to be brightened a little bit. But the biggest problem I see right now is the area on the north side of the building in shadow. This area is still too dark. Fortunately, exponential color mapping gives you the ability to increase illumination in darker areas. So I want to increase the dark multiplier value to do this. Before I do that, I've just realized I have a couple of things going on in the scene that are increasing my render times more than they should. First, I realized that I have blurry reflections in all my windows, which are always going to increase my render times. Also, I realized that I have a displacement map active on the object representing mulch in the scene. The displacement map was placed on the mulch to give it the appearance of having some relief, but after placing it on the object, I forgot to disable it in the modifier panel. But just to make sure I disable all glossy effects and all displacement maps I may have in the scene, I want to go into the global switches rollout and disable glossy effects and displacements. And just to show you the effect that each is having on my render times, I want to render with just the glossy effects disabled first. And this is what I get. I get about a 35% reduction in render time. Now I'll go back into the global switches rollout and disable displacements. And when rendered, you can see that my render time goes down about another 15%. Now I'm ready to increase my exponential dark multiplier, and I want to start with a value of 1.5 to see if that gives me additional brightness that I need. And with this change made, here's what I get. It's still a little dark all over, so I'll make one more adjustment to 2.0 and render again. And this is what it looks like now. I think this image has an appropriate level of illumination everywhere, almost everywhere. Earlier I mentioned whenever I place a light in my scene, I have to exclude background objects. I haven't done that in this project yet since adding the V-Ray Sun, and because of that I'm getting parts of my 2D trees in the background to be illuminated differently than other parts. The only way to pass off 2D trees as 3D trees is to illuminate all the faces the same degree. Otherwise, you're going to have what I have here, which is a noticeable change in the brightness on certain faces. The V-Ray Sun is not oriented to the area of the sky shown in this view, so the effect isn't so bad on this rendered image for the sky, but nonetheless, I should always exclude all of these background objects from the effect of any lights that I add to this scene. So I'll select the V-Ray Sun, go into the modifier panel and click the exclude button, and I want to select all the background objects in the scene and exclude them from this light. Notice that all my background objects begin with the prefix site-bg. I'm very big on naming objects properly, and having done so here in this scene, I can quickly select all the appropriate objects very quickly. And with these objects excluded now from the effect of the V-Ray Sun, I can see in the rendered image that my trees in the background look okay now. The sky is darker than what I like because the color mapping that I applied to it changed this. So all I need to do is increase the intensity multiplier of the Omni light, which is the only light source illuminating these sky objects. And right now I want to try a value of 1.5 and see what I get. When I do, I see that the amount of illumination I have on the skies so far look okay, so I'll leave it here just as is with this value of 1.5. I see one more little thing I want to tweak with the 2D trees. They seem a little bit too bright, so I'll quickly select one of the 4 instance direct lights surrounding my scene, which only have the trees included in its illumination. And all I want to do is reduce the multiplier on one of these lights to 0.5. These lights are instant, so change in one changes all 4. So when I render with this change, I see that the trees are illuminated just the way I want. At this point, I'm still working on the lighting configuration, which means I'm not doing anything yet to improve the quality of the rendering. By this I mean I haven't been trying to change quality settings, just appearance settings. I have a few more appearance adjustments to make before working on the quality of the image. And the next adjustment I want to make is to reduce this overly bright area of bounce light here at the roof's edge. Since the sun is very high in the sky and shining straight down or almost straight down onto the ceiling, the light is bouncing onto this eave here from the ceiling. The light's bouncing onto this eave and it has a lot of energy, and I want to reduce it. The easiest way I can do this is to select the roof object, open the V-Ray properties window, and change the amount of GI it bounces. To do this, I'll reduce the generate GI multiplier to 0.7, and this should be enough and not too much of a reduction. And when rendered, here's what the change looks like. And this area now looks good, so I'll leave it here as is at this value. I could have also made this change. I could have had the same change done using the V-Ray override material, which, if you remember from Module 7, is a great way to change the amount of GI or the color of the GI that's reflected off an object, despite what the diffuse color looks like. And I could have just simply copied the base material into the GI reflection channel and toned down the diffuse color in the GI reflection channel. Either way would have been fine. Either way would have yielded the same result in the end. The next appearance change I want to make is to make these harsh shadow lines throughout the image not appear so harsh. And the only way I can do that with the V-Ray Sun is by increasing the sun's size multiplier. Changing this value changes the size of the disk that you would see simulating the sun in the sky, but the side effect of this, and probably the more beneficial effect of this, is that the shadows in your scene get blurred. I'm going to try a value of 5.0 and see what this gives me. I can't always know for sure what this value is going to give me. It's not quantifiable in any way that allows me to say that 5.0 is going to give me a good amount, but just from experience, this is a setting that I typically use to get a nice softer look to the shadows. But I also want to make sure I don't see the sun in any of my views. So, and I don't want to see it in reflections because this disk, this sun being at this size, would look very unrealistic. So I'll enable the invisible option, and with these changes made, the rendering looks like this. The shadows are just right. They're not too sharp and they're not too blurred. Now, I might not see the effects of this next change from this view, but one of the things I always want to do when I make shadows blurry, whether with a V-Ray Sun or with area shadows using a standard light, is to ensure that no noise appears in the shadows. Since the subdivision multiplier within each light controls the noise, I want to increase this value to about 20. And just to see if this has any effect, here's what it looks like before this value is increased, and here's what it looks like after this value is increased. Not much change to the image itself, but also not much change to the render time, so I'll leave it here as is. The next change I want to make is to place a V-Ray displacement modifier on the grass. And I want to start doing this before I implement higher quality settings, because it'll just make rendering with a displacement take longer. So since displacements can significantly increase render times, it wouldn't make sense to add displacement to all the grass that I have in the scene, because this would be a large area and this would just simply take too long to render. I have a selection set made that already includes all the grass and 3 different cameras that I have in the scene, and I want to isolate these objects for a moment so that I can demonstrate what I do in this type of situation. What's important to note is I have 3 grass objects. I started creating the site by cutting the various parts out of a simple plane object with numerous length and width segments, which is why you see these segments shown here. And by the way, these added segments just ensured that I got a good boolean cut and didn't have a lot of skinny faces, which booleans don't like. But anyway, once I created this inside grass immediately surrounding my project, I added an additional larger plane which stretched to the boundaries of my sky objects, and this effectively created a boundary between the horizon and the ground. This prevents the background color from showing anywhere. You never want to see the background color showing. You never want to have a break between the sky and the ground. After this, I cut this rectangular shaped area representing the project boundary out of the larger plane, and I named this outer plane Site Grass Outside. Since this object is separate from the rest of the grass immediately surrounding my project, I could apply a less maintained looking material to it if I wanted to. But the really important thing I did is I cut a section out of the object called Site Grass Inside, and this area I cut out represented the area that would be close up in my 3 camera views. So on all 3 of my grass objects, I have a grass material applied, but on this particular object shown close up in my cameras, I want to apply the V-Ray displacement modifier and get the effect of nice 3D grass. I don't want to place it anywhere else because it's going to be too far from my camera and it's not going to be noticed. It could add render time, and it would add render time if I use the displacement everywhere else, but I wouldn't see the effect. So I only isolate this area of the grass. I only want to apply the displacement to this part of the grass, which is why I cut this area out of the larger piece of grass that represented the grass right around my project. So at this point, I'll select the V-Ray displacement modifier, and I want to use this black and white bitmap image shown in the material editor and add it to the texture map slot within the modifier. Since a bitmap is a 2D map, which I can see by opening up the material map browser and selecting 2D maps, since the bitmap is a 2D map, I can use 2D mapping or 3D mapping. I can't, however, use a 3D map, which is what a procedural map is. I can't use a 3D map such as noise with 2D mapping. So if you use a noise for your texture channel, you have to use a 3D map. But here I can use 2D mapping. There's really no difference or benefit in using 2D or 3D mapping here, so I'll just use 2D mapping. I want my grass to be about 5 inches long, so I'll use an amount of 5 inches in the modifier. And as a side note, I placed the grass about 1 inch below the concrete sidewalks and the curbs in the scene, so this 5 inches will really appear to be more like 4 inches tall. Earlier I had disabled displacement, so now I have to re-enable it so I can see the displacements in the rendering. And once I do this, I can render, and the result is this image here. Notice that my render time increased from 1 minute 32 seconds to 3 minutes 10 seconds here in this image. A little more than double in render time just because of an area that only takes up about 1/10 of the entire image. So this gives an indication of just how much displacements can add rendering time to your scene. Well, this looks fine, and I don't need to adjust it anymore, so I can go ahead and disable displacements again. And before continuing on, I want to point out something else. Notice in the rendering without displacement how much brighter my building appears than after the displacement is applied. The ground is simply brighter without the displacement, and more light bounces up onto the building than after the displacement is applied. It's a small enough amount that I probably won't have to adjust my lighting or color mapping, but I can always make small adjustments once I get closer to the final rendered output. Well, I've made all the adjustments that I want to for appearance. I made all the appearance adjustments I need, and now it's finally time to make some quality adjustments and get the rendering looking really nice. The very first thing I know I need to change is image sampling. I know that since I have a lot of fine details and a lot of blurry reflections, I need to use the adaptive QMC method. I have a lot of details that have to show up, like grout lines, which are not showing up at all in some places. And I have a fairly large amount of my image comprised of blurry reflections. Adaptive subdivision doesn't handle details and blur effects well, and fixed just won't allow me to take advantage of the large areas of the image where I don't need as much high level of pixel subdivision. Areas like my sky and even in the grass, where lack of image sampling is just not going to show up as much as smoother areas like on my walls or on my windows. So here the choice is simple, and I'm going to switch to Adaptive QMC. For test renderings, a min and max value of 1 and 4 would be just fine, but it won't be suitable for what I'm trying to get right now, for the quality that I'm trying to achieve right now. With a min and max value of 1 and 4, you can see I get a lot of fine noise and a lack of detail everywhere. Now, before I make the next adjustment, I want to highlight a common mistake a lot of users make with image sampling. Image sampling, in my opinion, is the most important and least understood area of V-Ray, and you've got to make sure you understand what's going on completely in this area if you want to minimize render times and maximize image quality. First, a lot of users try a max value of 100 and leave the minimum value at 1. But this is really a bad idea for a couple reasons. First, you'll never need anything even remotely close to 100 subdivisions, and if V-Ray ever attempted that kind of accuracy, the smallest of scenes simply won't render. Second, V-Ray will not always guess right, and having such a small minimum value will place your rendering at risk of having areas undersampled. To demonstrate this, I'll switch the max value to 100 and render again. When I do, you can see that very little has changed. There's noise all over this building, and I'm using a max value of 100, so you might think that I should see a much better image of this, but I don't. Yet notice the render time went up 50%, and hardly any improvement was to show for it. Well, in case you're wondering how much of the poor image quality is due to poor GI settings, I want to demonstrate the effect each is having. First of all, there's two types of noise in a rendering. Small fine noise like the white noise that you would see on a TV screen, and then there's large splotchy noise. Anytime you have fine noise, it's usually caused by image sampling, and anytime you have large noise, large splotches, it's usually caused by poor GI. And you can see this if I increase the irradiance map preset from very low to medium, which is my typical production preset, medium. If I render with this preset, notice that all the large splotchy noise that appears. And at first, it might appear that the GI is worse with this preset, but actually it's not at all. You only see more noise because you're seeing more detail in the GI. You're seeing more detail in the irradiance map. Detail that was previously blurred out with the lower irradiance map resolution. If you can imagine an image at a lower resolution, you just don't see the detail. Well, you don't see the detail with the irradiance map resolution, so the lower my resolution, the more blurred that the image gets, the more stretched it becomes when it's used for such a large image. And because of the increased detail, we can now see the grout lines better. But here, our ability to see the detail is hindered by the image sampling. Well, we increased the irradiance map detail, but we left the light cache at a very low subdivision setting. And to demonstrate that the noise you're seeing is not due very much to this low light cache subdivision setting, I'm going to disable secondary bounces altogether and render again. Now, without the secondary bounces, we have a little less illumination because there's no bounces outside the camera's view. There's no secondary bounces being added to the global GI solution. For an interior scene where light tends to be trapped more and bounce off of these secondary surfaces, disabling the secondary bounces would have a much greater impact than it does in this scene where there's really nothing outside the camera's view to even reflect light back onto the building, except for the ground objects and particles in the atmosphere. Notice something else that might surprise you. When I rendered with the light cache, the rendering took 3 minutes 58 seconds. But when I rendered without it, the rendering time actually increased to 4 minutes 26 seconds. And why would this be? Well, it's because the light cache quickly approximates GI, and the information that it calculates gets fed into the irradiance map and allows the irradiance map to complete its calculations faster. By turning off the light cache, the irradiance map doesn't get to benefit from the light cache, and it takes longer to calculate the information that the light cache would have calculated in much less time, although less accurately. Now here's where things get interesting. I want to reduce this QMC noise threshold value to 0.005 because I want to see if this global noise control can help reduce the noise of the GI. So I'll cut this default 0.01 value in half to 0.005 and render again. The result is a slightly noticeable decrease in the noise size in certain places, like just below the roof line here, but it came at a hefty price in render time. The render time increased more than 100%, going from 4 minutes 26 seconds to 9 minutes 37 seconds. And the reason for this huge increase had very little to do with the increased GI quality. Instead, it was because of the image sampling. Inside the QMC image sampler rollout, there's an option called Use QMC Noise Threshold. This option dictates whether or not image sampling noise is locked to the noise threshold value inside the QMC sampler rollout. This is a bad option to leave enabled, and in my opinion, it should not be a default option. By disabling this, you're telling V-Ray to use the color threshold value to specify the noise, and you're then able to adjust the noise threshold value without having to affect image sampling. The color threshold value of 0.01 is the same as what the noise threshold value was just a moment ago, which is why the render time goes back close to what it was before. The render time right now is 4 minutes 46 seconds, which is just a little bit greater than the 4 minutes 26 seconds that we had just a moment ago with the default noise threshold value. Therefore, by reducing the noise threshold to 0.005, the GI noise was improved a little bit, but with the image sampler locked to this value, it would be unwise to lower this value below 0.01. With the image sampler disengaged from the noise threshold, I could safely reduce this value, but it's really not the thing to do right now. I still have to get the irradiance map looking better if I'm going to get a nice rendering, so I'm going to try to change one of the most important settings first in the irradiance map, the hemispheric subdivisions value. Increasing this value can drastically increase your render times, especially in large scenes. And here I'll increase it to the default value of 50. But when I render, you'll see that it has very little effect on the quality of the irradiance map, although it increases the render time about 30 seconds. This is not the option you want to change right now, and I rarely ever increase this above 20. In some cases, increasing this value from 20 to 50 can double or triple the time it takes you to calculate your irradiance map. Far more important than increasing sample quality, which is what the hemispheric subdivision value controls, is increasing the information in between those samples, which is what interpolation controls. Watch what happens when I bring the hemispheric subdivision back to 20 and double the interpolation samples from 20 to 40. It has the effect of smoothing out the blotchiness, just like adding interpolation steps to a curved spline will make a spline smoother. The render times will certainly increase when you interpolate like this, but this is the setting that most affects splotchiness right now. You could increase the irradiance map resolution right now to make the splotches smaller and therefore not need to interpolate so much, but that could really increase render times on a high poly scene, and I don't think taking that approach would be the best course of action right now. Well, at this point I know a couple things for sure about this scene. First, increasing the irradiance map resolution and decreasing the noise threshold value will definitely help reduce the size of the noise, and increasing the interpolation will definitely help smooth out that noise. Knowing this, I can stop working on the irradiance map right now and look to the light cache. I want to reduce the interpolation samples back to the default value of 20, and I want to increase the noise threshold value back to the default value of 0.01 to make working on the light cache a bit faster. Now I'll enable light cache again. So with these values, the render time is reduced about 50% down to 4 minutes. And remember that the most important setting within the light cache rollout is subdivisions, and this directly controls the number of samples taken. For a DVD quality render size such as 720 by 486, I recommend a range of 1000 to 2500 for production renders. I'm rendering a bit larger than this right now, 1024 by 600, but I also know that the light cache is not as critical in this scene since there's so few secondary bounce surfaces and its impact is going to be minimized. I'm guessing a value of 1500 will do just fine. I'll leave all the other settings at their default value, and when I render, I see that the image changes very little. Despite the small change, I want to use this value during the final render, but right now I think I'm finished playing with the GI and it's time to move on to the final step in getting the image quality right, and that would be image sampling. To make test renders go quicker, I'll switch the light cache subdivisions to 150 and the irradiance map preset to very low. And when I render, you can see I get a lot of fine noise and a lack of detail everywhere. Within the image sampler, there's 3 values I have to nail down: the min, max, and color threshold values. I know that even with a maximum value of 100 and a color threshold value of 0.005, I still have a tremendous amount of detail lost all over my building. From experience, I know that using a minimum value of 1 is just not going to give me detail anywhere I need it. I want to increase this value to 2 and see what that does to the image. And when rendered, I can see that the image quality goes up a tremendous amount. I no longer have an alias look to all the areas with fine detail, like the areas around the windows. I don't see the grout lines improving very much, but I know that it's only because I'm using such a low irradiance map resolution. I also know from experience that a maximum value of 6 is about the most I would ever need to bring out detail in the rendering, although I've gone up to 8 on occasion when render times just aren't as critical. But I can sometimes get away with a value of 5. So I'll switch to 5. I also know that unless I lower the color threshold value, the image sampler might not even go for the maximum subdivision value. And I want to make sure that it does, so I'm going to lower this value right now to 0.003 and see what that gives me. The result of these 2 changes is a significant increase in the detail everywhere in my image. This might be all I need to do with image sampling, but I can't know for sure unless I increase the GI quality and give the image sampler more information to work with. So the next thing I need to do is increase the irradiance map preset back to medium and the light cache subdivisions back to 1500. Now when I render, I see all kinds of detail coming out, most notably the grout lines that were previously missing. But just to make sure that I can't improve the image with even better image sampling, I want to try my typical production preset values of 3 and 6. And with these 2 changes, I don't see much improvement in the image. But I want to try increasing the irradiance map resolution one more time before giving up on the 3 and 6 min-max values. One change I want to make before increasing the irradiance map preset is increasing the interpolation samples, which I know is going to need to be increased. So I'll use a value of 40 and see what this gives me. When rendered, I see that the splotchy noise is reduced. Now I'll try a high preset on my irradiance map. And the result is a significant increase in the sharpness of the grout lines. And this is good, but I want to caveat this noticeable improvement with a warning about how much using such a high irradiance map resolution can increase render times. Here you can see that it increased my render time by about 50%. And this is not a good thing, and it's because of this dramatic increase in render time that I almost never resort to using this preset. It's obvious that the grout lines were improved and some detail was brought out, but at some point you need to determine whether or not the increase in render time is justified. One other very important note that I want to make about image detail and noise in any scene is that whenever a surface is illuminated with direct light, you don't need such high quality GI in image sampling. Whenever surfaces are in shade, like the north end of this building, or when they're illuminated with low light, they'll always require higher settings to achieve the same level of quality. And with that said, you could always render part of your scene with higher settings. In this case, I could render a region in the north end of the building here separately from the east side of the building that's in direct light. For the purposes of this tutorial, I'll leave the preset at high and make just a few more changes. And first I want to try smoothing out the splotches a little bit more, so I'll increase the interpolation samples to 60. And re-render. And the result is a noticeable improvement and a 25% increase in render time, but I still have a noticeable amount of splotchy noise. So one more adjustment to 100, and I see that I get a virtually noiseless image, yet another 50% increase in render time. And the last change or test that I want to make before calling this image complete is to see if I can get some of the render time back by reducing the image sampling color threshold value. I know this value has a tremendous impact on render time, so I want to make sure that I don't have it set unnecessarily too high. I want to put it back to the default value of 0.01 and re-render. And when I do, you can in fact see that I reduce my rendering time by about 30%. I know from past experience that I really don't want to go any higher than this value because it can really start to affect image quality. But here I can see that the image doesn't suffer at all, so I can leave it at this value. And the only thing left to do at this point is to enable glossy effects and displacement, and we can render a final image, which is what you see here. If you want to see the completed scene at this point, you can open up the file called Hampton02.max. Now, as I stated in the beginning of this module, I want to demonstrate several different methods of lighting and rendering this scene. The module up to this point has been fairly thorough about one particular method of lighting, which is the typical process that I use to light and render a scene. On occasion, though, I use a couple other methods to complete the rendering process, and I want to highlight them here briefly before ending this module. In Module 7, we looked at progressive path tracing and what a great tool it can be if you just aren't having any luck with the quality of your image and you don't have the time to test a bunch of different render settings and material settings in order to figure out how to remove imperfections. It's also good because it can give you an idea of what your image could and should look like if you do find those optimal settings. Finally, it's a good method to render when it's at the end of the day or the end of the week and you have the time available to render for a long period of time. If you leave at the end of the day and you know that you won't be back at your computer until the next morning, it might not matter whether the rendering completes in 2 hours or 12 hours. This method is usually much slower than the radiance map and light cache method, but with this method you can be certain that when you come in the next morning you'll have a decent looking image. With this scene, I'm fairly happy with the quality that I've achieved, but I want to see what the image would look like if I use settings that would give me perfect quality. I use the term perfect loosely because this method can't fix problems with the setup of your scene's illumination, just the settings that control the rendering process. So what I want to do right now is switch the primary bounce engine to light cache, switch the light cache mode to progressive path tracing. I need to disable anti-aliasing, and finally set the light cache subdivision value. Remember from Module 7, all these changes have to be made in order to use progressive path tracing. I want to achieve a noiseless image, but instead of rendering the entire image, which could take many hours, I just want to render a small region and see how the image looks like in that small region. I only want to render about a 200 by 200 pixel region, and I want to render a region of the image that is most apt to receive poor GI. As I've stated before, surfaces without direct light are most apt to have noise, and so I want to make sure that the area that I test is one of these areas that give me low GI quality. In Module 7, I stated that to get a noiseless image using progressive path tracing, you need to shoot at least 1,000 rays per pixel, although you can sometimes get by with a little bit less in areas with direct illumination or direct light. This north end of the building, however, will almost certainly need 1,000 rays per pixel because it's in shade. To determine what subdivision value I need to use, I'm going to use a calculator. So I'll open up the calculator and I need to multiply the number of pixels that I'm rendering, which is 200 by 200, and that equals 40,000. So I have 40,000 pixels. I need to multiply 40,000 by 1,000 rays. So 40,000 times 1,000 equals 40 million. So I know I need 40 million rays shot, and knowing that the subdivision value is the square of the number of rays shot, all I need to do is take the square of 40 million, and I know now that to get a noiseless image using a 200 by 200 render region, I'm going to need at least 6,324 subdivisions. So I enter this value in the light cache rollout and render the image. When I start the rendering, it takes a few seconds for V-Ray to determine how long I have to wait for the rendering, but after a while the estimated render time stabilizes and I see that I'm going to have to wait about 8 minutes to have this number of rays shot and to see a noiseless image. Although I could stop it at any time and see a finished rendering. To show you what it looks like at each minute along the way, here's what it looks like after 1 minute of rendering with progressive path tracing, and it's full of noise. After 2 minutes the image improves a little bit, but you still see a lot of noise, and as I keep progressing with each successive minute, you can see that the rendering improves a little bit each time, and after 8 minutes I get something close to a noiseless image, although to get a perfect noiseless image I have to go even higher than 8 minutes. But this would at least tell me if I need to improve the settings in my render scene dialog box or improve my material settings. This tells me if I have in the previous rendering configuration a good setup and potentially a perfect GI solution. So from this final image, you can determine whether or not you want to try to do any more work to improve the quality of the GI in your scene. If I had all night to render the entire image, I would probably have a noiseless image waiting for me the next morning. Another method that can be used to render the scene is the QMC method. Remember from Module 2, I discussed a couple reasons why you might prefer this method over the irradiance map and light cache combination. Because it's so simple and easy to use, you can animate objects without having to worry about a GI solution, and when rendering animations, you can render immediately instead of having to wait to create a separate light cache, a separate radiance map, and hoping all the while that you've created both of those at a high enough quality. And another reason this is a really nice method, and this is really huge for a lot of people, you don't have to worry so much about running out of RAM because the QMC solution uses far less memory than the light cache and the radiance map. You won't notice this unless you're working on a large scene or in a high enough polygon scene, but when you do, and when you run out of RAM using the light cache and the radiance map method, you'll often have no problem rendering if you switch one or both bounces to QMC. So in this scene, all I need to do is switch both bounces to QMC and increase inside the QMC rollout, increase the subdivision value to something higher like 50, and perhaps lower the QMC noise threshold value to something like 0.005. And when I do and render this, you'll notice a considerable increase in render time, but in many cases this is a minor inconvenience when compared to the benefits of using this method. And of course you would always want to do a couple of test renders to get that perfect mix of subdivisions and noise threshold. Well, at this point I want to return to the file that was configured with the light cache and a radiance map. And if you want to follow along with the remainder of this module, open the file hampton02.max. I want to do a couple more things with the scene before I end the module, and the first thing I want to do is render the scene with the V-Ray physical camera, and then I want to render a dust scene with and without an HDRI. I talked about the V-Ray physical camera in Module 7, and I mentioned how difficult it can be to use this camera if you don't understand the basics of photography. If you don't know what an f-stop is, or what the standard shutter speeds are, or any of the photography basics, then you really shouldn't be using this V-Ray feature. It will only add a layer of confusion to your work, but it can be really simple and effective if you know what you're doing, and I would have to say that what makes this feature most valuable is the ease at which you can incorporate motion blur and depth of field, and the speed at which V-Ray renders both of these. Here in this scene, I want to create a physical camera and place it in the exact same location as the standard camera that I've been using so far to render the scene. And I want to do this so I can compare the renderings I've already done to the next set of renderings I'm about to do. So I go to the V-Ray physical camera, go in the top view, and just drop in the physical camera anywhere in the top view. And once I do that, I want to use the quick align tool to make the physical camera occupy the same location as the standard camera and make the target of the physical camera occupy the same place as the standard camera's target. And after placing the V-Ray camera in my scene, I know that I need to change the intensity of all my lights because unlike the standard camera, the V-Ray physical camera has exposure control built into it. So the V-Ray Sun, which was initially reduced to 0.015 when I first used it, now has to be returned to 1.0. And it can be adjusted from this point if necessary, but I want to return the V-Ray Sun to 1.0 anytime I insert a V-Ray physical camera. Now I have some other lights in the scene, a standard Omni light illuminating the background sky objects, and 4 direct lights around my scene illuminating the background trees. When the physical camera is used, standard lights need to have a far greater intensity value than when you use a standard camera. In this scene, I'm going to use a combined intensity value of 100 for all of my lights. So for the single Omni light, I need to use an intensity multiplier of 100. But for my 4 instance direct lights, I need to use a value of 25. Since these lights are instance, changing 1 changes all of them, and with 4 lights, each at a value of 25, that would be equivalent to a total combined illumination of 100 for all 4. And that will take care of the objects not being illuminated by the V-Ray Sun. Next, I need to adjust the V-Ray camera settings. The default camera settings are quite good with the exception of the shutter speed. The default shutter speed is 1/30th of a second, but this is not the typical speed that you would find with a typical camera. With the shutter open that long, you'll have a significant amount of motion blur with moving objects, and you'll always need to use a tripod in the real world to keep the entire image from being blurred from camera movement. The other effect from the shutter being open so long is too much illumination. If I render the scene with these default settings, you can see that the image is overexposed. The standard shutter speed of a typical camera is 1/125th of a second, so that's what I need to use here, at least to start with. If I make this change and render again, I get an image that is very similar to the image taken with a standard camera. But again, here the big benefit is quick and easy depth of field and motion blur, which you'll only get, by the way, by enabling these 2 options at the bottom of the modify panel. If you want to see the final version of the scene using the physical camera and the settings that I've adjusted here, open up the file hampton03.max. Now the last thing I want to do in this module is create a sunset and nighttime render of the scene both with and without the use of an HDRI. To do this, I want to return once again to the file hampton02.max. And for this demonstration, I want to continue with the use of the irradiance map, the light cache, and the standard camera. Now, whenever you create a nighttime image, you have to adjust all sources of illumination. The sources of illumination in this scene are the V-Ray Sun, the V-Ray Sky Map, and the lights used to illuminate the background. There's actually lights positioned, light fixtures positioned around the outside of the building, but the material used is a light material and it's having a very minor effect. You don't see its effect in a daytime scene, and you really need to adjust these, and we'll adjust these in a little bit and see how they can impact your overall illumination. But the main source of illumination I want to adjust right now is the V-Ray Sun, the Sky Map, and the lights for the background. The nice thing about using the Sky Map is you don't have to guess what illumination you need to set it to, because its illumination is tied directly to the sun, or it can be tied to any other light in your scene, so you don't have to adjust it necessarily every time you adjust the V-Ray Sun. So here all I want to do is drop the V-Ray Sun down in the sky so that it's about 5 degrees up off of the horizon. And I want to do this in a side view. And of course, doing this causes the Sky Map to adjust automatically, but it does not automatically adjust the lights for the background objects. So once I have the sun in position, I need to select the Omni light that I have in the scene and change its intensity so that it's a fraction of what it is now, so that its illumination that it casts on the sky is equitable to the illumination that the sun is casting on the building. And I'm just guessing that 20% of what the value is now, 20% of the illumination that I have now, is what I would need to set if I'm switching from a midday sun to a sunset. So I'll drop the intensity multiplier from 1.5 to 0.3, and then I'll have to drop the total illumination on the background trees. Remember that I have 4 direct lights, so I need to adjust the multiplier so that it's, for one light, I need to adjust it so that it's 1/4 of whatever percentage change I want to make. Knowing that I want to reduce the total illumination to 20%, I can change this value to 0.1. to get an illumination reduction that matches the background sky objects. So with these changes, I can render, and what I get is a decent sunset image that can still be tweaked, but nonetheless gets me close to where I want to go. I simply need to play around with the light intensity and the color mapping to get the exact look I want. And adding real lights would also help. This is what I would consider a sunset image, but if I want to get a nighttime rendering, all I need to do is drop the V-Ray sun farther down in the sky so that it's actually below the horizon. If I place it about 5 degrees below the horizon, I will also need to reduce the intensity of the other lights in the scene, just like I did before. So I need to select the Omni light again, and I need to drop its intensity again to a fraction of what it is right now. So I'm going to pick about 1/4 the intensity. So I'll go from 0.3 to 0.08. And for the direct lights, I'll try to drop it the same amount. So I'll try a value of 0.025. So now when I render, this is what I get. An image with just a small amount of skylight. But to make this image really nice, I would have to add numerous lights on the building and around the site. Although there are already numerous light fixtures positioned around the outer first floor walls, they don't actually have lights within them. The illumination that you see is the V-Ray light material on the light bulb object within the light fixture. I could always use real lights instead of or in conjunction with the light material, and doing so would almost always be better than just using the light material. It usually gives you a lot more control, usually renders a little bit faster, and usually just gives you a better appearance. But rather than going into the time-consuming process here, placing lights all over the building and for the site, for the purposes of this tutorial and in the sake of time, I'm just going to use what I have already set up and demonstrate a few things. First, I want to make the light from these fixtures illuminate a larger area, so what I'll do first is select the group of light fixtures, right-click this group of fixtures, and I want to select the Object Properties window. And from this window, I'll disable Cast Shadows and Receive Shadows. Doing this keeps the light fixtures from blocking light from the light material, and the result is a greater area coverage. So this light from the light bulb goes through the fixture itself and basically radiates outward without being blocked by the fixture itself. So I don't always do this, but from this distance it will look just fine. If I open up the material editor, I can see that this light material has a fairly small intensity value of 2, and I want a much greater area of light, so I'll use a much higher value like 800. And when I do, this is what I get. But a common problem you'll often run into when using the V-Ray light material combined with strong color mapping is a very alias look to the edges of the light. So to reduce this effect, you'll usually need to enable the subpixel mapping and clamp output options within the color mapping rollout. And you want to do this a lot of times when you're using high intensity lights, HDRIs, strong color mapping. Anytime you see white spots or alias edges between white areas like what you see with the V-Ray material and darker pixels around the edge, you want to use these two options, subpixel mapping and clamp output, to reduce this effect. So when you do, in this image you get a noticeable reduction in the alias look. Well, the last thing I want to do with the scene is illuminate it with an HDRI. Remember from Module 5, there's two methods of implementing HDRIs, through the environment rollout and through the use of a dome light. The dome light option enables you to achieve a much higher level of quality, so this is the option that I want to use here. So I'll select the V-Ray light, switch to the dome type, and in the top view I'll just drop it anywhere in the scene. Remember that the placement of the light doesn't affect your scene. The orientation would. If I rotated this light, it would certainly rotate the orientation of the skylight. The position doesn't matter, but it's a good idea to raise it off the ground slightly because you can see hot spots appear sometimes on the ground or anywhere that it's close to an object. And I always want to make this light invisible, so I'll enable the invisible option. And within the texture channel of the dome light, I need to load the V-Ray HDRI map type. Once loaded, I need to drag an instance of this map into the material editor and click the Browse button and find an HDRI that I want to use. I'm going to use a fairly decent HDRI here, one that's about 3,000 pixels across, and although I can't distribute this HDRI, it's really just a matter of finding a high quality HDRI that has an illumination in the image that's similar to what you want to apply to your scene. With an HDRI loaded, I need to set the mapping type properly, and in this case, I'm using a spherical map. Try to avoid large increases in the HDRI multiplier value, as that'll prevent your rendering from having the same illumination that you see in your HDRI. The key to a good quality HDRI is a large number of stops, a high range in intensity from one point in the image to another, and a decent resolution, especially if you're going to use the HDRI for the background. So with this HDRI, my image looks like this. As a final note about HDRIs, I'm often asked how often I use them and why. And my usual answer is I use them when I'm trying to achieve a unique and different look from the typical renderings that I produce. Users often have the same look to their renderings because they use the same materials and the same light settings, the same light approach, and it's nice to be able to have time and play around trying to achieve a unique look, and HDRIs make doing this very quick and easy. But I would have to say also that I personally find HDRIs most useful in images that show a low amount of illumination. In other words, I wouldn't bother using them to create a scene with a midday sun because I can set up and render a scene with a real light much better and much faster than I can with an HDRI. I would, however, save some time setting up lighting for a nighttime scene using HDRIs rather than using multiple low-intensity light sources. Well, that's everything that I wanted to discuss here in Module 9, and I want to spend just a few minutes reviewing some of the key points that I made. On this slide, I've placed the final settings that were used in the final daytime rendering and some of the key settings from other features used later on. I've only placed those settings that are different from their default value. And obviously, throughout the course of the test renders that I did, I changed a lot more than the settings that you see here, but a lot of the settings ended up being reverted back to their default value. And of all the settings available in V-Ray, really only a small percentage of them were actually different in the final rendering than their default value. When I do a project like this for real, I go through almost all these steps that I demonstrated here in this module, with the exception of renderings that I conducted just to make a point. But the overall process is still the same. I start with typical test render settings, conduct a test render, determine the major problems in the scene, make adjustments, make these adjustments one setting at a time so that I can isolate which settings are causing the problems, make adjustments at extreme values to find the optimal mix between speed versus quality, and achieve a good quality rendering, and then try to experiment to see what settings I can reduce in terms of quality, what settings I can reduce to save some render time without noticeably reducing the image quality. And the settings that I adjust first are those that usually have the greatest impact on speed and quality. So here in this scene, I use adaptive QMC for image sampling with a min-max value of 3 and 6, which I find works well a good majority of the time. Sometimes 2 and 5 works well enough, and if I can get away with this configuration without a reduction in quality, then I'll use these values. And even though the QMC noise threshold value turned out to be the same as the image sampler color threshold value, don't forget to disable the use QMC threshold option every time you start a rendering. I used a high preset for the irradiance map in the final configuration for this tutorial to show how much you can bring detail out, details like grout lines, but in actuality I would almost never do this because if this rendering were rendered at high resolution, which it would be if it needed to be printed, details like the grout lines would end up showing just fine. And if it were an animation at DVD quality size, the details would still show up fine, and I would have no flickering problems because the details would be blurred somewhat with the video filter that I would almost certainly have to use. You should always start the hemispheric subdivision value at 20 and increase it only if necessary. The high interpolation value I used helps smooth out the splotches, which really start to come out when you start to increase the irradiance map resolution, which is yet another reason why I try to avoid a high preset. With the high preset, splotches are harder to smooth out than with a medium or low preset, and therefore I need a higher interpolation setting, and my rendering time not only increases drastically with the high preset, it increases because of the higher interpolation setting I need. The light cache subdivision value was set to 1500, and although it may not seem that it was necessary to set it this high because of its minimal effect on the lighting in the scene, using it sped up the irradiance map calculation, so whatever time it added I got back anyway with the quicker irradiance map calculation. Color mapping was adjusted a few times, and I settled on a configuration that added light to really dark areas without increasing light in the really bright areas. You can never know for sure what configuration is going to work best until you experiment. Now, the clamp output and subpixel mapping options were also enabled for the nighttime rendering, and for darker scenes they often need to be used, but I actually needed to use them for this third view of the scene because when I did a test render of this view I had small white dots appear in several places on the cars. The more reflective your materials are, the higher the intensity of your lights, the stronger your color mapping, and the sharper your anti-aliasing filter, the more likely you are to see these kind of imperfections. And these two options are the best way to fix these imperfections. With the standard camera that I used the V-Ray sun multiplier value of 0.015. But when I switched to the V-Ray physical camera, I reverted back to the default 1.0 intensity. I also increased the size multiplier value of the V-Ray sun to get that blurred look to the area shadows. I used a V-Ray sun throughout this tutorial, but in actuality I could have used the other great option for the sun, and that's the standard direct light. I could really achieve almost a duplicate rendering by using this type of light. And if I placed this type of light in the same location, enabled area shadows, adjusted my light intensity and color, I really could have achieved a similar image in a similar amount of rendering time. Finally, with the V-Ray camera, I always recommend starting the shutter speed at 1/125th of a second and leaving the other two important options at their default value whenever you have a bright sunny scene. The other two important options, film speed, which is set to 200 by default, and f-stop, which is set to 8, are good settings to start with. If you make your scene darker, just refer to the exposure setting chart from Module 7 to help adjust these values accordingly. Well, this does it for a very long Module 9. Hopefully the methods that I used in this module make sense, and hopefully you'll be able to achieve the same level of speed and quality in your work. In the final module, Module 10, I'll present some techniques to light interior scenes.